In this lecture, we're going to talk about solving problems. Solving problems is one of the most important things in programming. So if your goal is to become a great programmer, you need to learn how to deal with problems effectively. So in this video, I will show you how to think as a developer by solving problems using a simple 4-step framework. And let's use our friend John again. So after some time, John can code now. He is almost job ready at this point, but he still needs to work on his problem-solving skills. And in programming, when we say solving problems, we mean a real problem that needs a real solution. For example, in an array of GPS coordinates, find the 2 closest points. And this problem is not straightforward, right? There are a lot of steps involved in solving this. And so we need a way to effectively solve problems like this one, or even way more complex ones. So problem solving does not mean to fix coding mistakes or bugs, alright? Anyway, whenever John encounters a problem that he needs to solve, he usually just jumps at the problem without much thinking. He also implements his solutions in an unstructured way without much of a logical approach. This makes him stressed out when things don't work right away. Another problem that John has is that he is too proud to research when he doesn't know how to come up with his own solution. So all of this is not effective at all. It makes John waste a lot of time. Now the first fix to this is to always stay calm and slow down and not just jump at a solution without having a plan. Also, when solving problems, you need to be in a mindset of taking a logical and rational approach. After all, programming is just logic, alright? Then, when you are in the right mindset, just use my 4-step framework to solve the problem at hand. And the first step of the framework is to make sure that you 100% understand the problem. Step back and take a high-level look at the big picture. And the most important part of this step is to ask the right questions in order to get a clear picture of the whole problem. And the best way of understanding this is probably to look at an example together here. So let's say you are working at some company on some project, and then your project manager comes and tells you, we need a function that reverses whatever we pass into it. And that's all you know about the problem. But do you understand it 100%? Well, probably not, right? I know that I don't. So let's ask the right questions to get there. First, we can ask, what does whatever actually mean in this context? So what should actually be reversed here? Well, and if we think about it, it only makes sense to reverse strings, numbers, and arrays. Objects don't have a well-defined order, so we can't reverse them. We're also not gonna reverse like undefined or null or a boolean, right? Then, after we have that figured out, we can ask, what should we do if something else is passed in that is not a string, number, or array? How are we gonna handle that? It's also relevant to ask, what exactly should be returned from the function? For example, should it always be a string, or should the type be the same as was passed in? Well, in this case, probably we should always just return the exact same type that was passed in. Also, we can start to ask more solution-oriented questions, like how to recognize whether the argument is a number, a string, or an array, or how to actually reverse a number, a string, and an array. So these are just some of the questions that we can ask here. I'm sure there are more, but this should already give us a way more clear picture of this problem. Now, right now, at the beginning of your journey, you will probably not yet know what the right questions actually are. But don't worry, this will come with time and practice, I promise. The next step is probably the most important one, which is the divide and conquer strategy. Divide and conquer means to break up the big problem into as many small problems as possible, because these small problems are then a lot easier to solve. And this also ties in with the previous step, because by dividing the problem into subproblems, you also take the big problem apart until you understand it exactly. So based on the previous step, if we wanted to break down this problem, we could define a couple of subproblems. First, we need to check if the argument is a number, a string, or an array. And this is, in fact, a small subproblem, right? So now we can just solve this one in isolation and then move on. The next subproblem is to implement reversing a number, then implement reversing a string, and then implement reversing an array, so that we are ready to deal whatever is passed into the function. Finally, we then also need, of course, to return the reversed value. So these are our subproblems, and they kind of look like a task list that we now need to go ahead and implement. And this is great, because it makes our work so much easier now. Now, sure, this example is a pretty simple problem, but this strategy works just as well for bigger and way more complex problems. In fact, divide and conquer is an essential method of problem solving that is also used a lot outside of programming. Anyway, with this, we have actually already covered the two most important steps of the framework. But now let's say that we actually do not know how to implement one of these subproblems. Well, in that case, we should not be afraid of doing as much research as we have to. Now, of course, we should always first try to implement a subproblem on our own, using our own coding abilities. But if we're constantly hitting a wall and cannot move on, then we should waste no more time and just find out how it works using Google or a questions and answers website like Stack Overflow or the MDN JavaScript documentation. We will see how to use these in the next lecture when we're going to work together on a real problem. And actually, researching is a huge part of a programmer's job, as you will find out very soon. So you really should not be ashamed when you don't know enough to solve a certain problem. That's just completely normal. Now, in this case, some questions that we could Google are how to check if a value is a number or an array or a string in JavaScript. Or we could Google how to reverse a number or a string or an array in JavaScript. Okay? And again, we will do this in the next lecture on a real problem together. Finally, in case we are trying to solve bigger problems, we should put all the previous steps together and write some so-called pseudocode before writing the actual code. And pseudocode is simply an informal description of the actual code that we're going to write. So it's like code for humans to understand, not computers. For our example, the pseudocode might look something like this. So you see, we use some structures of a programming language, but this is clearly not JavaScript, right? And there are no real rules on how to write pseudocode either. You just write so that you understand it yourself or other people on your team. So in this example, we just start by naming the function as reverse, and then we basically pass in a value. Then we say that if the type of the value is not a string and not a number and also not an array, then simply return the value back. And that's because, as we defined previously, we only want this function to work for strings or for numbers or for arrays. And again, you can clearly see that this is not any valid JavaScript at all. But anyway, if the type of the value passed this initial test, then we say if the value is a string, then reverse the string. If the value is a number, then reverse the number. And if the value is an array, then simply reverse the array. And then at the end, we want to return the reversed value. Okay? So this is really more like a list of instructions that we now could go ahead and actually implement using the JavaScript language. Okay, and that's it. That's the 4 steps to solve any problem, no matter how big. And now, before I leave you, a final tip I can give you is to develop a genuine curiosity and passion for understanding how things actually work, not only in programming, but really in the whole world around you. For example, the famous scientist Richard Feynman was repairing radios when he was just a teenager, and Elon Musk made his first computer game when he was 12. And there are many more examples like this, and all of them became geniuses in their fields, in part because of their genuine curiosity on how the world around them works. Alright, and with that being said, let's now go ahead and solve a real problem in the next lecture using this framework that we just learned about. Let's now solve together a real problem using the framework that we just learned about, and also tools such as Google, Stack Overflow, and MDN. And here is our very simple problem. So let's say that we work for a company that builds a smart home thermometer, and our most recent task is this. So, given an array of temperatures of one day, calculate the temperature amplitude. And keep in mind that sometimes there might be a sensor error. And they give us this array of data. So, what should we do here? How do we solve this problem? And this is actually a pretty simple problem, but it still shows us the fundamental logic of solving problems. Again, using the framework that I just showed you before. And so the 2 most important parts of that is to understand the problem and to breaking up the problem into smaller sub-problems. So let's start by understanding the problem a little bit better by asking some questions. So first of all, they want us to calculate the temperature amplitude. But what actually is that? So we can write that down here. What is temperature amplitude? And the answer to that is that it's the difference between the highest and the lowest temperatures in the array. So answer, difference between highest and lowest temp. And so this is the value that we will have to return from the function. Then we might ask, well, that's quite nice, but how do we actually calculate the highest and the lowest temperature in an array? So let's write that question. So how to compute the max and min temperatures. And finally, they also tell us here that sometimes there might be a sensor error. So what does a sensor error look like? So what's a sensor error and what to do when one occurs? And here the answer is probably to just ignore the error. Now here from our data, we can actually see what an error looks like. So it's this string here, which says error. Okay? But it's good to have an idea of all of these questions so that we now really understand the problem that we need to solve. And so I think with this here, we do have a pretty good idea. So now, given our understanding of the problem, let's try to break the problem up into smaller sub-problems. So first, we need to make it so that the sensor errors are actually ignored. So as I was saying, the answer to what to do here is to just ignore the sensor errors and simply work with the rest of the data. So, how to ignore errors? Then another task is going to be find max value in temperature array. And then another task is to find the minimum value. And another task is going to be to subtract min from max and then return it. So subtracting min from max is of course the amplitude. And so that's what we need to return. And so all of these are simple steps, but it's good to have an idea of how we will solve this problem. And so that's why I wrote down every single step of the way here. So let's start writing a function. So although they don't tell us that we should write a function here, whenever we encounter a task like this, it's a good idea to write a function for it. So let's call this function calc temp amplitude. And so this function will receive an array of temperatures. So let's again just call that temps. And so now we are going to start to work on solving this problem. And let's start here with finding the maximum and the minimum value in this array. We can deal with the errors a little bit later. Now, probably we don't know yet how to do that based on what we just learned, right? I mean, we already have the tools for sure, but this requires a little bit of thinking. And if we don't know yet how to think about this kind of problems, it's a good idea to do some research. And so we will now use Google to research how we can find a maximum value in an array. And so that's what I meant when I said we should do some research and use Google whenever we need to. So what I like to do is to just write JavaScript and then be as descriptive as possible of what I want to achieve. So let's say get max value in array. And so don't be afraid to ask Google this kind of questions whenever you're stuck yourself. Now we get here a couple of replies, basically, but I'm interested in showing you Stack Overflow now. So Stack Overflow is a site of questions and answers, and most of the time someone already had the same question as we have. And so then they ask that question on Stack Overflow, and we can then go there and find a response. And this one here sounds good, right? Find the min-max elements of an array in JavaScript. So let's click on that one. But now here the problem is going to be that at this point, you will not understand most of the solutions. For example, this one here talks about prototypes. This one has like this weird apply and math. And so let's just scroll until one that we can better understand. This one has this weird dots that we will go into later. But here we actually have something that we can understand. So let's focus on this solution here. Okay. And usually the first solution is always the best one, or the first or the second. But in this case, we just scrolled a little bit more so that we can find a solution that we can implement with the tools that we already learned about. So what they're doing here is to start by defining the first element of the array as max. So in the beginning, they basically assume that the maximum value of the array is the first element. And then from here, they loop through the array or over the array. And in each iteration, here, they test if the current value is greater than the maximum value. And if it is, then the new maximum here becomes the current element in the array. Okay, does that sound like a good idea? Well, I think that it does. So let's try to implement this ourselves, and then I will try to explain you a little bit better why this is a good solution. So let's create a for loop here. And of course, we don't need to copy the code here from this site. Usually it's best to understand the solutions and then trying to implement it on yourself. So not copying the code exactly from Stack Overflow. So let's start with the counter I. Let's start at 0 as always, even though here they're starting at 1. But never mind, we will just do it like we have always been doing it. So I must stay below the length of the array that we're looping over. And in this case, that's the temperature array, right? So temps dot length and then I plus plus. Okay. And actually, before we do the loop, we need to create that max variable that they have here. So let's do that. Let max equal the temps array, so the very first element. So again, we will start by assuming that the first element of the array is the maximum. And that's because we didn't loop over the array yet at this point. So this is similar to the challenge in the last section, where we started out with a sum set to 0. So that was a good starter value. And in this case, a good starting point is simply the first value of the array. And now let's implement that logic here. So if the current value of the array, so that's temps at position I, so the current position is greater than the current maximum value, then the maximum value will become this new value. And that makes sense, right? Because if the current value in the array is greater than the maximum, well, then that value should be the maximum, right? And so that's what we then do here. Okay, and now let's simply log it to the console. And remember that from now on, I will start using the snippet that we defined in the first lecture of the section. So I just type CL, hit return, and then max. Okay, and now just to test this function, let's call it with an array of just some values. So 3, 7, and 4. And so now it's very obvious what the result should be. And so I already saved it, and so probably we now already have the result here in the console, because remember, we still have the live server here running. And so it automatically reloaded the page, and we get the correct result here, which is that 7 is the max value. Let's add something else here, like 23. And now 23 will become the max value. And so the logic here works. So let's get rid of this one, and just to analyze what happens. So in the beginning, before we even start the loop, the max will be the first element of the array, so 3. Okay? Then the loop starts at the first position, so that's 3. So here, then we ask, is 3 greater than 3? No, it's not, so nothing happens. Then in the next iteration of the loop, we are at 7. So then the question is 7 greater than 3, which is the current maximum? And yes, it is. And so now max equals 7. Okay, next iteration of the loop, which is 4. And so the question is 4 greater than 7, which is the current maximum? No, it's not. And so nothing happens, and then we're done. And so the result in the end is that max is equal to 7. All right? Does that make sense? So we solved this problem here, so this sub-problem, where we found the max value. But now we need to do the same for the minimum. And hopefully you can see how that one works, because it's pretty much in the same way. So let's say min, and we will start at the same starting point here. And all we need to do now is to add another line to this loop. So we can do it all in one go. And so now what we're going to say is, if the current temperature is less than the minimum, then that should become the new minimum. So min equals the current temperature. And actually, since we're using this here so many times, let's create a variable for that. So const current temperature is equal to temps at position I. And now I'm selecting and then Command D or Control D, 1, 2, 3, 4, and replace all of this with cur temp. Okay, and now just to see again if it works, let's log the minimum as well. And let's add some other value here. And so what can we expect when we save it? Well, the max should be 8 and the min should be 1. So I'm saving, and yes, that works. Next up, we can then tackle the problem of ignoring errors. So what that means is that we do not want to include this, right? Or in other words, this logic here should only run if we actually have a number here. Okay, so basically if the current element is a number, only then it makes sense to make this sort of comparisons. And so we can use something that we learned in the last section, which is the continue keyword. So let's say if the type of the current temperature, so type of current temperature is different from a number, then continue. And remember that continue means that the rest of the iteration will not be executed. So the current iteration will be finished and then it moves on right to the next one. And so in this case, what happens is as soon as the loop reaches this part here, since it's not a number, then none of the logic down here is executed, and then we move on to number 9 right away. Okay, so let's now actually call calc_temp_amplitude using our temperatures array. And indeed, we already have here the max and min temperatures. So let's confirm that that's correct. And yes, 7 is the max and -6 is the minimum. Awesome. So that works. Now there's only the easy part left, which is to return the amplitude. So return the max minus the min. Okay, let's get rid of this one here. And here, let's store that result into a variable, or actually amplitude. Okay, and then console log oh, actually there's an error here. This should be called amplitude. Okay, and so 23. So you can probably start to see that this is my favorite number, and so it comes up all the time here. Awesome. We did a great job here in solving this problem. And again, we did it because we first understood it correctly, and then we broke it up into these sub-problems. But now let's suppose that after we're done with our solution, the project manager tells us that the function should actually receive 2 arrays of temperatures and not just 1. But the rest of the function should work just the same. Okay, so, well, let's quickly write that problem down here. So problem 2, function should now receive 2 arrays of temperatures. So let's try to again understand the problem. So we can probably ask the question, when we have 2 arrays, do we need to implement the same functionality twice? And well, the answer is actually no. So the solution is to just merge the 2 arrays at the beginning. So just merge 2 arrays. And now we need to then again break this one up into sub-problems. And in this case, that's just, well, really just one sub-problem, which is how to merge 2 arrays. Okay, but we can see that this is probably the best thing to do, right? So imagine that we have this same function, but instead of receiving this one here, so just one array, it gets 2. Then if we can merge these 2 arrays into one, then the rest of the logic could stay exactly the same. Okay, and here the problem should actually be just merge 2 arrays. So that is our sub-problem that we will now solve. So let's now do some more research here. So I think we could actually come up with our own solution here, but really I just want in this lecture to use the tools that we have to solve problems on our own with research. So I want to show you how a developer goes about doing these things. So JavaScript merge to arrays. So we have here the Mozilla developer network that I told you about in the last lecture. And here we also have, again, a Stack Overflow reply. So let's take a look at the Stack Overflow again. So here we see that apparently there is like a concat method. So here we can also see array.concat. So that seems to be the solution. And I remember that previously on that Google results page, there was also something about that. So this first here, so the MDN page is also about the concat method. So let's now actually explore the MDN website a little bit. Okay? And let's make this a bit wider so I can show you how it really looks like. And so MDN looks like this. And once more, it might have changed by the time you're watching this video, but the core functionality will still be there. So there's always a short description about the functionality and then some quick examples. Then here on the left side, we can actually see all the methods about the array. Okay, and that's because we are right now on the page about an array method. So concat is a method of arrays, so similar to push or shift or includes, right? So concat is just one more of these methods. And again, we can see all of the methods here. And as I told you, there are a lot of them. So push, for example, is the one that we already learned about and used. So we can quickly see that. And so indeed, the push method adds 0 or more elements to the end of an array and returns the new length of the array. So this is kind of what we did ourselves previously. And actually, we can add multiple elements, which I didn't tell you by the time, but this here works just as well. But anyway, this was just to show you a familiar method. But let's return to concat here. So here is a long description of the method. Here is the exact syntax, which many times looks a bit intimidating. And so I like to actually stick to the examples here. So whenever you need to know how a certain built-in method or function works in JavaScript, you can always just look it up on MDN. This is really the complete but unofficial JavaScript documentation. And in fact, many of the things that I know about JavaScript come here from MDN. So don't be afraid of doing any research that you need on this page or also on Stack Overflow. Anyway, here from this example, we can understand kind of how the concat method works. So we have array 1 and 2, and then on array 1, we can call the concat method and as an argument pass in the second array. And the result will be array 3. And when we log that to the console, we will get A, B, C, D, E, F. And so that's the array 1, A, B, C, and then followed by array 2, essentially D, E, F. So I will just copy this syntax now and make this smaller again. And I will paste it here, just so we can then use it as a reference. Okay, and now I will get this whole function and not change that one, but instead create a new one. So calc temp amplitude new, and then here we also call the new one and call amplitude new. Okay, amplitude new. And now here we need to change the arguments. So remember that now this new function will receive 2 arrays of temperatures. So I'm just going to call them T1 and T2. Here at the beginning of the function is where we will solve our problem. So this subproblem of merging the 2 arrays. So let's again just put this here just so that we see it as a reference exactly where we need it. So what we want to do is to create a new array, and I will call it temps. And I'm calling it temps because that's the name of the complete array that we already have here in the function. So that used to be the name of the argument of the previous version of this function. And now I can just say the array1, so array1, which in our case is t1, dot, and then array number 2, which in our case is t2. And that's it. And now let's just log that to the console very quick. Temps, and we no longer need this. Okay. And here then we need to call this new function with 2 arrays. So let's just create 2 arrays. So 3, 5, and 1. And then another one, 9, 0, and 5. And now let's see. And here we see that it did actually work. So now we get this one array, which includes all the elements basically of these 2 arrays that we passed into calc temp amplitude new. So this function. And we can also see that 9 and 0 are the max and the min, and 9 minus 0 gives 9, which is then this new amplitude new. Awesome. So we solved this problem number 2 here successfully as well now. And yeah, so I hope that now you have a better idea of how to solve problems, and especially how to do research using the tools that I just showed you in this video. So that's Google, Stack Overflow, and also the MDN documentation. And this last one is, in my opinion, actually the most important one. I learned so much from MDN. It's incredible. So now in the future, whenever something is not working in your code, and even during the course, you can always try to figure out the solution on your own, for example, using Google or Stack Overflow. And so that will then be very helpful for your developer journey. So we talked about problem solving, which is a very important skill of any software developer. Now, another extremely important developer skill is debugging, which means to find and fix errors. So let's finish this section by talking about debugging to make you ready for the rest of the course ahead. So first of all, as you might already know, a software bug is a defect or a problem in a computer program. So basically, any unexpected or unintended behavior of a program is called a bug. And the actual term bug was coined in the 1940s when this real bug was causing an error in Harvard's computer. Now, there are many reasons for bugs in programs, but what matters here is that bugs are a completely normal part of software development, because we are humans, and humans make mistakes. In fact, every complex application contains bugs, which sometimes go undiscovered for years and can cause security holes or other problems. So really, don't feel bad if you introduce bugs in your own code. We all do it, even the most expert programmers. Now, luckily, not all bugs cause huge security holes. In fact, many bugs are quite small and simple to discover. So let's see a simple example. Remember, in our previous example, the goal was to reverse whatever was passed into the function. So let's say we finished writing the reverse function and call it with this array and get this result. But clearly something is wrong here, right? The returned value looks like scrambled, but not reversed at all. So this means that we must have a bug somewhere in our reverse function. Okay? To fix this, we use a process called debugging, which is essentially finding, fixing, and then preventing bugs. So let's see how that works. So the first step is to actually become aware that there is some kind of bug. Because, as I said, in a large application, bugs can actually go undiscovered for years. Now, discovering bugs usually happens during development, using automated testing software, or user reports during production. And bugs that are identified during production are the worst bugs, because it means that they went undiscovered during development and are now affecting real users of our application. So that's why it's really important to identify bugs early, for example, using automated tests. Now, while identifying the bug, sometimes we also need to take into consideration the context in which the bug happened. For example, certain bugs might only happen in a certain browser or only for certain users for some reason. Next, once we know there is a bug, we need to go into our code and find the bug. We need to isolate where exactly it's happening. And we can do that using the developer console that we already know. However, that only works for small bugs in simple code, where we have a good idea where the bug might be located. But if the code is more complex and we have no idea where the bug might be, then we need to use a debugger software. And I will show you how that works in the next video, because it's really important for the developer to be able to use a debugger. Anyway, once we know where the bug is located, we can finally fix it. So we can correct the bug. And this is probably the easiest part. So essentially, all we need to do is to replace the existing, so the wrong solution, with a new correct solution that actually works. As a final step, we should then prevent this bug from ever happening again in our codebase. For example, we can search our project for the same bug in similar code, like in a similar function. It's totally possible that we did the same mistake twice in our code. And if that's the case, we must fix the bug everywhere. A more advanced way of preventing bugs is to write tests using testing software. And I might add a bonus section on testing to the course at some point, because this is actually an important part of software development. Okay, and that's it. That's a broad overview of debugging in programming. And we really just scratched the surface here. Welcome back. So let's now put the debugging process actually into practice. And we're going to start really small and just fix a very simple bug using the console. So let's suppose that in our smart thermometer that we were working on before, we need to do some measurements in a unit called Kelvin, which is the absolute temperature. And the conversion to Kelvin is pretty easy. So all we have to do is to add 273 to the temperature in degrees Celsius. So let's very quickly create a function which will perform this measurement. And this is, of course, all completely fictional. And this function will actually take no arguments at all, because we will get the measurement from a command prompt. So we will basically pretend that the command prompt is like the thermometer sensor. And now let's actually create an object here. So an object for the measurement. So we haven't used objects in some time, and so let's remember that. And let's just set some arbitrary properties here. So the type of measurement is going to be temperature, and the unit will be in Celsius. So basically, we will measure temperature in Celsius, and then we return a converted version. And in there somewhere will be a bug. And now, finally, the value of this measurement will come, as I just mentioned, from a prompt. So let's just say degrees Celsius. And so that will then trigger a prompt. And then let's convert that to Kelvin. So as I said, all we need to do is to take the measurement in degrees Celsius and add 273. So that means measurement dot value. So this property here, where that value in degrees Celsius will be stored, plus 273. And now we can return converted value. And then let's run the function and immediately log the result to the console. So that's measure Kelvin. And now I will give it a save, and it will then ask me for the temperature. So let's say it's 10 degrees Celsius. And so now let's wait for the result in Kelvin. And we get this number, 10,273. And that is not what we expected. We wanted 283, but not this number. So there's got to be a bug somewhere. And so let's find it. And by the way, the first stage of the process was already this one. So A was to identify the bug. Remember? And now we're going to stage B, or stage 2, which is to find the bug. And so since the bug appears in the converted value, which is this one, and this one is derived from this measurement value, let's start by inspecting that measurement value in the console to see if something is wrong there. So console.log measurement.value, give it a save. Oh, and of course now we need to input it again. And so it looks okay actually, right? So it is 10, so that's exactly what we inputted. So it looks kind of normal. I just want to show something now to you, which is that we actually do have things beside console.log. So we also have console.warn and console.error. And with this, we can basically generate warnings and errors in the console. So 10 again, and you see that now this first one looks like a warning, and the second one actually looks like an error. So that's just a matter of formatting, but it's still interesting, I think. But let's take them out. And so, yeah, right now it looks like everything is correct. So let's dig a little bit deeper and take a look at the entire object. And actually, if it was myself, I would have done that immediately, but I want to show you the complete thought process here. So anyway, let's say measurement, so that's the entire object and not just the value. Let's turn off this one as well, give it a save, 10, and let's open up. And now we actually see the problem. You see, the value is a string. And that's because, as I told you in the last lecture, the prompt function here always returns a string. No matter what we input into that prompt window, it will always just be a string. And so that's why we get this end result here, because as you remember, the plus operator, when it sees a string, it will convert both operands to a string and then concatenate the strings. Just as another curiosity here, there is also another way of showing objects in the console, which is really handy sometimes. So measurement, and so again 10, and so console.table gives us this nicely formatted table. And especially for bigger objects, that can be quite helpful. And let's actually leave that here so that you can see it. So with this, we completed the second phase, and that was to find the bug. And now all we need to do is to fix the bug. So we need to do that right here where it actually occurs. Yeah, so up here. So let's see, fix. And so the solution to this is to convert this string that is returned to a number. So let's use the number function. So we already learned about this one in the last section. And so now we actually expect this to work. And indeed, now we get 283, which is exactly what we were looking for. Great. So this was a very simple example of just using the console in order to hunt down a bug and then fix it. But now let's take it to the next level and learn how to use a debugger in Google Chrome. And let me quickly show that to you with this current function. And for that, we actually need to make this a little bit bigger. And now we go here into Sources. So for the first time, we're using the Sources tab, and then click here on script.js, which is our current script. Okay, then as we move down, we have our code here. And now here in the debugger, which is basically these two panels here, we can set something called breakpoints. So let's put a breakpoint here in this line of code. So here, and we set a breakpoint by clicking here in this left bar. And so this will set this red point, which means that there is a breakpoint. And now when we reload the page, then the execution will stop exactly at this point. So basically execution will freeze in time and show us exactly what the execution looks like at that moment in time. And that includes all the values of all the defined variables. So let's do that. Let's reload. And so you see, now we are in this function. And now I can click this button here to resume the script execution. And it will then start going over all these lines. But now it can only continue if I input a value here. So that's coming from this prompt. So I put 10 here, hit enter. Then it does all of these lines here. And finally, we reach the line where I set the breakpoint. And so that's this one here marked in green now. And again, at this point, we can then see all the variables. So Kelvin is still undefined because the computation has not yet been done, but we can take a look at measurement here. So the value is 10 as we just inputted. And yeah, this can be very helpful in case that we don't want to mess around with a lot of console.logs or other stuff like that. We can also hover these here. So here we can see the whole object. Here we then can see just the property value. And now we can execute the rest of the function simply by hitting this step button here. So basically this will then go to the next line of code. So now we have Kelvin set at 283 because now the previous line just executed. And here we are in the last line. And so now we can see here return value will be 283. So with this one here, we can execute one line at a time. And for now, just ignore these three buttons here. You can explore them a little bit later. Okay, so we're almost done. Let's just click one more time. And so we're out of the function now. And now processing this next line of code. Let's just continue. And so now we went into some other stuff here, and that's actually coming from the live server. So never mind, we can just close this and now click here on resume script execution. And now we're done. So this is not all super intuitive, I would say. So just experiment around a little bit with these different buttons. Okay, now we just need to get rid of this breakpoint here. Otherwise, the execution will always stop here in the future. So just click this red dot here again, and then it's gone. And that's how we launch and use the debugger in Google Chrome. Now let's quickly introduce a bigger bug here in our code and then fix it using the debugger. And for that, I'm simply going to go back to this function that we created before. So this one here. And let's call this one here bug. So I will replace all the news with bug. So we have here cog, temp, amplitude, bug. And here we're calling that. And then we call the amplitude bug, and here as well, bug. Cancel that one. And actually, let's come here and comment out this piece of code so that it doesn't annoy us all the time. And we can just set the value here manually to 10 now. Okay, this way we preserve the code that we have and also keep it running, or actually keep it working. So here let's just say using a debugger. Then down here we are calling this function, and here let's just change this to something else. Let's say 4. Okay, Let's just run this now quickly. And so we see that the output at this point is still correct because we didn't introduce any bug yet. So the max is 9, the min is 1, and therefore the amplitude is 8. But now let's say that we did a mistake. And we might have thought intuitively that the max and min values would be good to have a starting point of 0. I think you can maybe see why that would make sense. So for example, we started the sum at 0 before, so why not start the max and the minimum at 0 too, right? It would have been quite reasonable to think that. And so let's pretend that we did think that, but this will actually introduce a bug, because with this will not work. So as you see, now here it says that the minimum value is 0, right? So that's coming from this console.log here, which says now that minimum is 0 and that the amplitude therefore is 9 minus 0, which is 9. So we identified the bug here, okay? Let's again write that identify. And so let's now go back here to Chrome and to the debugger to try to find that bug. And the debugger is actually especially useful inside of a loop. And so that's the situation that we have right now. So we are in a loop. And so let's see here now why the maximum and minimum values are not being correctly set. Or actually it's just the minimum. The maximum is fine, but still we need to analyze both of them. So what I'm going to do here is to set a breakpoint right here, because that's where the maximum and the minimum are being computed. Okay, so let's reload, and right away we get to this point in the execution. So at this point, the temps variable has already been computed, so it's already this complete array. Max and min are at 0, and so now we are doing this. So we see that the current temperature is 3, that the maximum is 0, and so next step will end up here. Or let's actually continue. And indeed, now we see that max is 3. And that makes sense, right? According to the rules that we described earlier. Okay, moving on here. Oh, and we already moved on right to the next loop iteration. And that's because we don't have a breakpoint here. So let's just put another one. And so now we're in the second iteration. And so now I is 1, as you can see here. Okay. So the current temperature is 5, max is 3, and so now the new max should become 5. And yes. Oh, and again we jumped over this one, but let's just keep going. All right. So now the current temperature is 1, max is 5, and so this one will now not get executed. So now we can see this one. Current temperature is 1, which is less than 0, and so nothing is going to happen, right? And so here we actually have the bug itself. So we know intuitively that 1 here is supposed to be our lowest number. But the problem is that 0 is even lower. And so it's impossible for any of these numbers here to be set as the minimum. Again, because the initial value that we set is already lower than any of the values that we have in the array. And so now, by analyzing this one by one in the debugger, we can really understand that is what happens. So again, in this situation is where we would like for this 1 to be set at a minimum. But it's not going to happen, because 1 is not less than 0 here. And so now there's not even a point to keep going. Well, we can still do that. So now the current temperature is 4, which is this one. And just one more. So I is 5. So we're in the last iteration. And we see that the maximum is already correct. And now here we can actually also see the loop finishing, because we see that temps.length is 6, and I right now is also 6. So 6 is not less than 6, of course, and so the loop will now finish. So you see, Now we jumped over the loop and we are finally here in this next line of code. Let's go to the next one. And the value to return is 9, as we already know, because of our bug in the min. Okay, and that's it. Now we stepped over this entire function logic and saw exactly what happened line by line. And again, we're in the live server here. Let's just remove this and resume the script execution. Okay, great. So I hope that got you an idea of how we can use the debugger. Just wanted to tell you that instead of going through the sources tab here, we can actually also call the debugger right from our code. And all we have to do for that is to write debugger right here. So JavaScript has this debugger statement, and then when the browser sees this debugger, it will automatically open up the debugger tool. So when I give it a save now, you see that we are right at this point. So it's like it put a breakpoint here in this point, and then we can do everything as we just saw before. So let's click here on continue. Or actually, let's just get rid of this here, give it a save, or stop this and reload. And yeah, then we exited that debugger. Now, this was, of course, just a small example. But again, this is an extremely powerful tool that you can now use whenever you run into a problem in the future. So take a moment now to go through the steps again, maybe by yourself, and that will then help you make you a better developer.